Hello, everyone. Very excited that you guys are in cast today. Always appreciate it. We got a really interesting topic, as always, as well. So, I'm going to give it a second, let everyone file in, come across the different platforms, whether you're on LinkedIn, YouTube, Twitch. If you're struggling with any of your streams, come on over to Twitch. It's the first comment. We're nice over here on the Twitch side, and you get a little bit better of an experience. Live chat, you can see your comments obviously on those other platforms, but the feed is a little bit nicer. The stream's a little bit clearer, and the video's a little bit crisper. Hoping everyone's having a good day. Whether it's the morning, evening, night. Hope you're having a good one. It's nice down here in the southeast U.S. It's a beautiful day. Let's put it that way. It's going to be a great one, right? So it's the morning for me. But we'll get rolling into it. So I am Rob Petrosino. For those of you who don't know, never met me before, I'm a futurist technologist and overall great guy. My role is to educate others about technology, get them inspired, and most importantly, make you feel like you are a thought leader and can go out and advocate for technology for your own organization or the organization that you work in. With that, we're going to be talking about a pretty cool topic today. Today's topic is virtual reality security and a pretty fascinating UC Berkeley report that just came out about 5 or 6 days ago. Making sure I have my adequate amount of caffeine this morning, which is going to be cool. Good. It's always good to have a strong cup of Joe in the morning. Alright, with that, we've got a pretty good audience rolling in. If you're on Twitch, if you're on LinkedIn, if you're on YouTube, feel free to throw in comments or commentary. I'll be happy to follow them and chat with them. And if you're on Twitch, make sure you hit that follow. It doesn't cost you a bit. I don't want your donations. I just want you to come on in and get educated. But we're going to head on over to the screen share. Alright, so UC Berkeley, several organizations underneath UC Berkeley put together a pretty interesting piece of paper that they put together. But basically, they were able to identify 50,000 plus virtual reality users from two different things: head and hand movement. So if we think back, first let's dissect this title. Okay, there's virtual reality. Virtual reality on the spatial computing spectrum is all the way on the one side where I completely lose the real world around me. I am fully immersed in a virtual world, versus the other end of the spatial computing spectrum, which is augmented reality, where there's digital information overlaid on the real world around me. Okay, so that's the virtual reality user. So a user, someone that's in this experience, and they're using unique identifiers to understand who this person is, what user it is, by just their hand and head motion data. Okay, now this is going to be a little bit complex. We're going to take it nice and slow, so if you have questions, always shout them out, throw them in the chat. But in short, what they wanted to do was acquire as high as a level of accuracy as they could, determining a user based on a short window of documentation, 5 minutes, okay, and allow them to be 94% accurate within 100 seconds of motion and 73% accurate within 10 seconds of motion. Okay, this motion is only from the head and the hands. Okay, well, how'd they do that, Rob? That's fascinating. That's really, really interesting how they identify those users. Well, that's what this paper is all about. Okay, so the first portion that they kind of go through here is just contribution, that type of stuff, and direct call out to all these individuals involved. Fantastic work, super interesting, well done. Kudos to you. Thank you for doing this type of work, because it helps others educate those about the security and risk potentially when it comes to the amount of data that's actually captured and can be stored from these types of devices, which is something that we didn't really do when it came to cell phones and Facebook and MySpace and Twitter and Instagram, etc. Wasn't really thought about back then, and when those things came out. But it's good to see that this work is being done. So they used 55,000 real VR users across 40 different countries with 20 different types of VR devices. So the interesting thing about that is that they have to distill down the pieces of information that they actually get, so that they're consistent across all of them, right? So good data in, good machine learning; bad data in, bad machine learning. What they went through though is selecting a specific VR game which has an incredibly high number of users and acquiring a lot of the information that happens via the headset. So they they asked basically people to sideload in their tracking system, and for their head-mounted displays and two handheld controllers, they track that data. For those of you that don't know, controllers have 6 degrees of freedom, or 6 DOF right here, which basically measures how you rotate or angle a specific controller. So that is one of the pieces of information, as well as how the head is moved. So you get anywhere between 60 to 144 pieces of data per second, which is really, really interesting. So that's called the telemetry stream. What they wound up doing is they wound up taking the game Beat Saber, okay, which is right here. This is a nice little screenshot. The user stands on the floor. If you've never played Beat Saber before, here's a quick overview. You stand on the floor. You're wearing a head-mounted display, a headset, a VR headset, and when you swing your controllers, there's 2 sabers that are out of it, and you are able to cut through different blocks. Okay, there are blocks here. One over here is destroyed, one over here is not destroyed. There are walls that you have to move around. Okay, you might be realizing how, as I do these different actions, what the data was collected. So as I move my hands and chop these blocks, and as I move my head to avoid walls and these bombs, I am creating a massive amount of data. And that data set is actually really, really interesting. So since May 2022, they had 50,000 users post over 2.5 million scores from the Beat Leader platform, which is the side-loaded open source Beat Saber extension. So that's what they did. They used that information and they obtained 3.69 terabytes of data. Okay, that is a massive, massive data set. Very, very large. And that data set was everything from metadata, telemetry, context, and performance. So we're not going to break down these too much, but what we're saying is that information was held and then classified using just some classic machine learning. So what they used was models and decision trees to aggregate this data and compare them to each other. So from this data set, they can say user 1 in 5 minutes, this is their profile. So we've captured the first 5 minutes. When they come back and replay, can we accurately identify them using that head and hand motion? And the way that they were able to capture that or derive that is from this beautiful motion telemetry data graph right here, which does a really good job of explaining the information that they captured. So we're going to go from guiding principles over to this motion one on this side. So what they wound up doing was they documented how users cut through these blocks, and you can see this is 5 Beat Saber users hitting the same block pattern, and identified that a single user swipes through a block in a very unique way, and the user does it in a unique way with their right hand and their left hand. They also move their head in a unique way. So by combining the head movement, the slashing movement, and the telemetry that comes from both during these, they're able to identify users. Now, the motion captured, this is really, really low level data that's identified, right? So what we're getting is an X, Y, and Z tracked path from each controller, which is great, right? So I'm just getting these arcs, this red and blue arcs from both the hands on how a user cuts through these blocks depending on the different location that they are, and the head movement that happens when I'm moving through these. So as I go and create this profile, this 5-minute profile, it's easily being able to be compared by a machine learning system to say this is the actual user, this is the reference information of that user, and this is who they are, and to an extremely high degree of information. So they're taking hand, left, hand, right, and head, and using this to build a profile. What I really want to call out though is they only use classic machine learning, right? So what they're doing is setting a data set, refining off that data set, and ultimately driving a training process to boost the acknowledgement of the machine learning system to a specific user. They really didn't use deep learning. Even to the point of saying, we found that deep learning empirically fails to perform well in our study, which requires more than 50,000 classes. Still, it's larger, sophisticated deep learning models could achieve strong performance in the future. So they actually went down the path of using deep learning. Deep learning, a subset of machine learning. We won't get into too much craziness about it, but basically think about a machine being able to train itself on a data set and do identification versus machine learning, where it's much more human decision tree derived. Okay, so they go through, they're able to do this, and now contextually, you're able to see how a user cuts through these blocks, what degree and cut angle is created, and the various motion and features of them. Okay, so as I swipe from a specific angle, knowing what angle that comes from to hit a certain block, and how those repetitive actions happen, and how I use my head to move around, that's identifying. Also, they go on later to talk about how head height is a very interesting feature. So they use 22 contextual features from the block, and then 105 dimensions pre and 105 dimensions post. And these features were the hybrid featureization of 232 dimensions that they're able to analyze, right? So these is the different analyzing features that they had, and then how these actions actually happen through the block is really, really deeply interesting. Now they overlay all of their hierarchical machine learning approaches to say, okay, we think that these users interact in this way, this is how they're going to do it, and layer on these different machine learning algorithms. And the way that they did it was kind of through just straight regression testing, or testing against this data set. When they had 5,500 classes that were presented, they needed to make sure that the memory utilization of the machine learning set also yielded an accurate amount of training time, or they were correlated, right? So depending on the number of users, depending on the number of time, right, the more users you have, obviously the more time that it takes to analyze that information and data. But what's nice is eventually you get to correct classification of users more quickly with a reduced amount of memory, because the model is fine-tuned to what you want it to do. So to kind of give you an idea of results, based on the seconds of test data per user, so from 0 seconds, what's interesting is that there's like a 50% accuracy here in like less than 20 seconds, right? At 20 seconds, they're 85-ish% accurate. In 10 seconds, they're 70-ish. In 5 seconds or left, they're basically 50% accurate, which is really, really interesting. Imagine being 50% accurate on a decision within 5 seconds. It's crazy. So at 100 seconds, they're driving well above 90% accuracy. And they did this through a layering of that machine learning data, identifying the replay users, having a core set of user identification and features, and using that as differentiators between each other. So it's really an interesting piece of information, documentation, and research for identifying users, and being able to track users that may feel anonymous but are 100% not now. And the reason that they're not is because you may not be able to drill down into a specific user's information, but you may be able to drill down and identify a user who feels that they are anonymous by just switching their username, because we have this body tracking. Again, this is just taking 3 pieces of data, 2 controllers, and head movement, and allowing that to be used. The one thing that they did call out is the head height. Head height of a user is auto inputted. people will change their head height when playing Beat Saber for a better performance based on the leaderboard. So you can actually maximize your performance based on where you adjust your head height to your actual head height. So instead of just tracking head height and using it as an individual contributor, they actually use the motion of the head, which is a really good piece of data and learning that they found, that these user inputted pieces of information, although interesting and viable, they may miscalculate or misdetermine who the user is in the machine learning system. So valuable data versus not valuable data. Really, really crazy. As this kind of comes to fruition, they make a really interesting statement right here at the end. As we slowly realize the increasing role that virtual reality has and the metaverse may soon play in our lives, more attention should be given to the security and privacy implementations of these platforms. That's probably the biggest understatement of the century, considering your phone has about a third or half the number of sensors a headset does. So that amount of data is pretty critical, making sure it's secured and done in the right way. So really, really, really well done piece from UC Berkeley, and ultimately shows us that the security and compliance that may happen or may need to happen is far beyond what original users were thinking when it comes to augmented virtual reality and metaverse styles. But imagine being able to track a user just based on how they're interacting with different objects in the virtual world. And that can be done in the physical world as well, right? The more data that we provide externally that can be housed into a specific data set and can then be trained upon, the more and more identifying information we give. This is very early on, but is a little bit of a precursor to some of the stuff that we've seen related to facial recognition software and tracking, right? Instead of now using facial recognition tracking, we can quite literally determine a user just based on their movements and very short window of time of their movements. 5-minute data set and then 100 seconds to pair that user back to that information. So that's today's Tech Talk. A little bit of an interesting one for sure. I appreciate you guys coming in. If you ever have questions, feel free to reach out across the platforms. The socials are down below. I look forward to chatting with you again soon, and I'll see you guys on the other side.